absolute value inequalities. So you've been doing some inequalities, linear kind. Now we're going to change the game. So just to make sure you're going to be good, I'd like you to solve these two equations. So go ahead and pause, and when you have them both solved, come on back and check your answers. All right, let's check those answers. So for the absolute value problem, we have -6 and +2. And for the quadratic problem, after doing the factoring, we end up with 1/3 and 2. Now, if either of these are giving you trouble, it would be a really good idea to do a little searching and review how to solve these before continuing with the video. You could also arrange a time to meet so that we could work it out. Let's move forward for those who are ready. Here's another one that we've done before. I want you to solve and graph this inequality on a number line. Again, pause, and when you're ready, come back to check your work. Welcome back. So we changed to an equals. We solved and got 3. Because of the original less than, that's an open circle on 3. Tested 0 on that number line. It was false, and so we shaded x greater than 3. Now, there's one thing that's been happening a lot with the work I've been seeing. I've seen everything on this screen except that final x greater than 3. You must write that final inequality or you actually haven't solved this problem here at the start. So make sure you get that final step there. All right, so an absolute value inequality is just like an equation, only we have to use that trick of the number lines. So this is where the strategy of change to equals is really important. Now, if you're one of those people who really honestly would like to solve it as it is with the symbols in place, then you should reach out and we can talk about how that's done. It involves memorizing some rules and exceptions. Let's take a look at solving this the way we have. First thing we're going to do is change this to an equation. So there I have it, change to an equation. Now I'm going to solve it like I normally would. So absolute value always has two options. 2x minus 7 could have equaled -13. Why? Because of that look inside strategy. If I look inside the bars, a -13 would come out as positive, or +13 would come out as positive. So those are the two options. So I solve each one and I get -3 and 10. Now I go to my number line and I'm going to plot those two answers. Since the original problem said less than or equal to, I put solid circles on -3 and +10. Now, here's what's going to be the challenge. Because there are two dots on this number line, it actually cuts it into 3 regions. There's the left of -3 region, the in between the two dots region, and the right of 10 region. So I'm going to test one value from each region. And because I'm kind of lazy, I usually pick the first good number. So from region 1, I'm going to grab -4. It's the next one in line. From region 2, that's where 0 lives. I'm picking 0 because it's the easiest. And from region 3, the first good number in there is 11. So that's what I'm going to pick. You can pick anything you want as long as it's in each of the regions. So it's totally up to you which values you would like to choose. So I'm going to test those. When I test -4 in the original problem, I end up with 15 less than or equal to 13, which is false. When I tested 0, I end up with 7 less than or equal to 13, which is true. And when I tested 11, I got the same result as -4, and it was false. So now I know where my solutions live. Only region 2 was true, so the solutions live in region 2. So my x is going to be bigger than -3, but also smaller than 10. So I'm going to now write my final inequality. Remember, that's a key step. And I'm going to shade my graph. So x had to be greater than or equal to -3, less than or equal to 10. And there we go. How about you try one? Go ahead and pause and see how it goes. Welcome back. Let's see how it went. So I solved by dropping for my two options, got my two numbers, plotted them. I tested 0 from the left region, 4 from the middle region, and 6 from the right region. And the left and right were true, but the middle was false. So then I just gave the appropriate symbols to show that I shaded less than 3 and greater than 5. All right, so now on to quadratic inequalities. These work the same way. You change to equals, you solve, you graph, you test, you get your final answer, and you shade. So with this one, here's my original problem, 3x squared minus 7x plus 2 greater than or equal to 0. So I changed to an equation, factored and solved, because this is the one you did at the beginning of the video, and there are those same two answers, x equals 1/3 and x equals 2. So I plotted 1/3 and 2 on my number line, using my filled in circles because the original symbol said greater than or equal to. Then I tested 0 from my left region. That was true. I tested 1 from the middle region. That was false. And then I tested 3 from the right region. That was true. So I did my shading and then wrote down what I shaded. X less than or equal to 1/3, x greater than or equal to 2. So you can see this is the same as absolute value. I'm still just solving, and like absolute value, I'm getting two answers, and so that makes 3 regions to test, and then I'm writing my final solutions after I shade. So let's just kind of go through this. I want to make sure we have our steps. This might be a good slide if you want a screenshot or put it in your notes because it's the steps of what to do. You change the problem to an equation. You solve that equation. You graph whatever you get on a number line. If it says greater or less than the original problem, it's an open dot on the solutions. If it said greater than or equal to or less than or equal to in the original problem, that's going to be the filled in dots. You then test one value from each region in the original problem. Don't forget, you always go back to the beginning. Then you shade where the solutions live. And then in bold and underlined and made huge and made red, you must write the final inequalities. If you were taking a test and didn't do that step, the problem is wrong. You must make sure you do that final step. So, next up, I'm going to give you a chance to try using 6 inequalities from our CPM section. So I'm going to give you all 6 at once. Pause that video, solve, graph, and try them all. What I did after that is I put up the large section slides for each problem so that what you can do is visually you can see if you want to skip. So you can check problem A by getting to the solution for A and then pausing. If A is all good and you feel good about it, you can then just skip to the section slide for problem B and check that one. If you don't understand and you just need to hear the problem explained, instead of skipping to the next problem, just unpause the video and the problem will be explained. So that's how you can do it. The large section slides will allow you to skip problem to problem so you only have to listen to the problems you need, not have to listen to all 6. So hopefully that makes sense. Here are your 6 inequalities. Go ahead and pause and see if you can solve all 6. With E, for some weird reason, CPM had an extra absolute value bar just sort of hanging around. that was a typo. So here are your 6. Pause and come back when you're ready. All right, we're going to start with problem A. Here's the solution. Pause while you check. If you're back, it's because you needed a little explanation. So I changed to equals. I looked inside that absolute value and knew that x plus 2 had to either equal -1 or it had to equal +1. So then I subtracted 2 in each case and got -3 and -1. Since it started as greater, I used open circles on my 2 numbers. So then I tested -4 from the left region, -2 from the middle region, and 0 from the right region. And it was my left and my right that turned out to be true. So I shaded my left and my right, and then I went back over to my work and wrote x was less than -3 because that's what I shaded, and x was greater than -1 because that's the other part I shaded. All right, go ahead and pause while you check the answer. If you've replayed, it's because you needed some explaining. So I changed to equals, and then I used Xbox to factor x squared plus x minus 12. That's where I got x plus 4 and x minus 3. So then I set each parentheses equal to 0 and solved and got -4 and 3. So I plotted -4 and 3 on my number line. I tested -5 from the left section. It was false. I tested 0 from the middle section. It was true. And I tested 4 from the right section, and it was false. So I knew my solutions lived in between -4 and 3. So I went and wrote my inequalities: x greater than -4, x less than 3. And just as an extra little thing, whenever a solution falls in between 2 numbers like this, we can actually write the solution using a more compact notation that shows x between -4 and 3. So imagine taking that x greater than -4, totally flipping it around like a mirror and overlapping the x's. That's how you get it. All right, go ahead and pause while you check your answer for C. If you're back, here's your explanation. I changed to equals. Now, the problem is 0. There is no -0 or +0. There's only one answer that's going to work here. Whatever makes the inside of my absolute value equals 0. So I solve and got 1. Well, that just leaves me with one number on my number line, solid dot because of the original symbol being greater than or equal to. And then I thought, well, I'll just test 3 in my original problem. So I put in 3, and I got 3 minus 1 was 2 times 2 is 4, and I got a true statement. So everything to the right in my right region was the correct answer, and so I put in x greater than or equal to 1. Go ahead and pause while you check your work for problem D. If you're back, here's your explanation. So I changed to equals, then I added 1x to both sides and added 4 to both sides. That's where 10x and 10 came from. Then I divided by 10 and got 1. So I put 1 on my number line, solid because it said less than or equal to in the original problem. And then I tested 0 in the original problem, and it was true. So I was shading that left side where 0 lives. And then I wrote the final inequality that goes with that, x less than or equal to 1. Go ahead and pause while you check your work for E. All right, welcome back. If you're here, you need some explaining. So I changed to equals, and then I tried to make 2 equations using what I thought was what we've done before, and I got 2 answers. But when I went back and tried to test regions, nothing worked. So then I went back and looked at the problem and realized, wait a second, if I look inside, there is nothing I can put in absolute value bars that would equal -2 when it comes out, because absolute value only spits out positive numbers. That means that even though I tried to solve, there were no solutions. So the answer was no solution. Go ahead and pause while you check your answer to F. Okay, if you're back, it's because you needed a little extra help. So I changed to equals. Now to get rid of that square, I went ahead and did the square root to both sides. And when you do square root, you know that makes those little parentheses stand up straight and tall as absolute value. So then I had to do my two different answers. And then I solved by adding 2 to both sides. I was feeling kind of lazy and didn't change that square root of 7 until I absolutely had to. And so then I did 2 minus the square root of 7 and 2 plus the square root of 7, and I rounded to the hundredths. So here are my two decimal answers. And so then I went and put both decimal answers roughly where they go on the number line. Here's a little secret. If you label weird answers like this, as long as your dot is reasonably close to the number you say it is, so long as you've labeled it, you're all good. So it's important to label if you're putting in decimals like this. So I put in my decimals. I use -1 from the left region, 0 from the middle region, and 5 from the right region. And it turns out it was the left and the right that were the good ones. So I shaded, and then I wrote the inequalities that match. So that ends our work on quadratic and absolute value inequalities. If you're having trouble, feel free to go back and review. If not, good luck, and you've got some problems to work on.